Hello everyone, welcome to this Apache Tomcat webinar. Today's topic is going to be connector selection. In terms of an agenda, I'll do a quick introduction, then go on to look at the various connector options and a little bit of the background of each of those. I'll briefly discuss the major features and differences of each of the options, and I'll wrap up with some recommendations. If you have any questions, please type them into the chat window as we go along, and I will get to them at the end. So for those of you who don't know me, my name's Mark Thomas. You'll find me posting on various Tomcat and other Apache mailing lists under Mark T at apache.org. Fairly heavily involved in Tomcat, currently the Tomcat 8 and Tomcat 9 release manager, and the focus of my work at the moment is on the development of Apache Tomcat 9. So let's get on to the connector background. Start off with HTTP, and if we go all the way back to Tomcat 4.1, that just had the Java blocking IO connector, which we generally refer to as the BIO connector. And that used Java Secure Socket Extensions, JSSE, for its TLS implementation. Things didn't really change in Tomcat 5, and then in Tomcat 5.5, a connector based on the Apache Portable Runtime library was added. That's the same IO library that Apache Web Server, HTTPD, is based on, and it uses OpenSSL for TLS. The reason for doing that was primarily the view that OpenSSL would be a lot faster than JSSE, and generally that's the case. More on that a little bit later. In Tomcat 6, we had access to the Java new IO, so we refer to that as the NIO, and that connector was added in 6, and again that uses JSSE for TLS. Not much happened in 7, and then in 8 there was another Java IO implementation available. So again, a new connector implementation was provided for HTTP. The Java implementation was called NewIO2, so rather unimaginatively, we called our connector the NIO2 connector. And again, that uses JSSE for TLS. Generally, all of these new connectors were implemented on the basis of, well, there's this IO library available. Let's implement it, let's see how it performs, let's see what it's like, how easy it is to use, and so on. And what we're always doing is looking for, is there something better than what we've got at the minute? In Tomcat 9, we actually dropped the BIO connector. I'll explain why in a little bit. So we actually removed one of the available connectors in Tomcat 9, but we added the ability to use OpenSSL for TLS with the remaining Java connectors, which was the NIO and NIO2. Look at that in summary then. BIO with JSSE, that's available from 6 through 8. APR is available for all current versions, as is NIO with JSSE. NIO2 with JSSE is available from 8 onwards, and NIO and NIO2 with OpenSSL, that's 9 onwards. Let's have a quick look at AJP. That's a slightly more complicated history. It brought a little bit more baggage along with it, and it took us a little bit longer to clean that up. Back in the days of Tomcat 4.1, there was the old JK connector, which was already on the way out, and something called the Coyote JK connector. They were completely independent connector implementations. By the time Tomcat 6 came along, we dropped the old JK connector and added a BIO and APR connector implementation. The thing with those two new implementations is they shared a lot of common code with the HTTP connectors. The Coyote JK connector and the old JK connector, they were, as I say, completely independent, and they didn't share any of the code with the HTTP connectors. By the BIO and APR implementations that were added in Tomcat 6, they shared a lot of code, and that eased on maintenance, reduced code duplication, all those sorts of good things. Tomcat 7, we booted out the Coyote JK connector, and we also added an NIO implementation. Then in Tomcat 8, that tracked HTTP rather, and where we added an NIO2 implementation. And in 9, we dropped the BIO implementation. You'll note with AJP there is no reference to TLS. AJP doesn't support encryption, so TLS isn't really a factor when it comes to AJP. So we'll just quickly summarise that. Coyote JK, it's there in 6 still, but I really wouldn't recommend people use it. I'm not actually going to mention it again in the rest of this presentation. BIO, as with HTTP, it's there from 6 through 8. APR is there for all versions. NIO arrived a little bit later in AJP. It wasn't there till 7, and NIO2, as I said, is available from 8 onwards. So what are the key features of these connectors? Well, the BIO connector first. That's written based on blocking I/O, and it worked very well with servlet blocking APIs, so that the standard servlet input stream, servlet output stream. It wasn't particularly well suited when servlet 3 async came along. It was even worse when servlet 3.1 non-blocking came on, and it didn't work particularly well with the WebSocket implementation either, because again, that's non-blocking. So we were starting to have all sorts of problems with BIO. We were effectively simulating non-blocking whilst we were really blocking under the covers. The code was getting a little bit messy in places, and the general direction of movement is towards non-blocking I/O styles. So really, BIO was past its prime, which is primarily why it was removed. It has 1 thread per connection, and that doesn't particularly scale well. So if you imagine a standard HTTP connection, you have some request, gap during keep alive, next request, big gap, next request, big gap. And the thread is just sat there during those big gaps, not really doing anything useful, using up resources. And threads tend to be one of the things that systems are limited by. So it doesn't scale that well because you needed a thread per connection. So what we had to do to make it scale was effectively disable HTTP keep alive. And once 75% of the thread pool is in use, then HTTP keep alive is disabled, and all subsequent connections will not use keep alive, and that has a knock-on impact on performance. It was, when it was first written, the simplest of the connectors. That really changed over time as we had to try and support these various non-blocking schemes, as I said. And it uses JSSE for TLS, which is generally slower than OpenSSL. More on that generally comment shortly. If we look at APR, that has the advantage that it can switch between blocking and non-blocking. And we've actually taken increased advantage of the non-blocking features in later Tomcat versions, not just for the servlet 3 async, the non-blocking I/O and the WebSocket, but also for other parts of the standard servlet processing in Tomcat that just lets us be that little bit more scalable. It only uses a thread when a connection actually has some data that needs processing. So that gives you much greater scalability than BIO, which always had to have 1 thread per connection. So what you have is a pool of threads, and you have the polar, and the polar manages the connections. And when a connection has some data to process, the polar takes the thread from the thread pool, passes the connection to it, sends it away to process it, and then when that processing is complete, the thread goes back in the thread pool, the connection goes back in the polar, waiting for the next data to turn up. So that way you can manage many more connections than you have threads. Now, because it uses the Apache Portable Runtime, which is a C library, it's using native code. One of the advantages of that is it's potentially faster. One of the disadvantages is if things go wrong, and they don't go wrong very often, but occasionally they do. If they go wrong, then there is a chance that the JVM is going to crash. So that is a slightly greater risk when you're using APR. Big advantage is that it uses OpenSSL, which is generally a lot faster than JSSE. The NIO connector, as the name suggests, that's non-blocking. It does have to simulate blocking for the servlet I/O, but that's not a huge amount of overhead, and it's well suited to the other non-blocking aspects of the async, non-blocking, WebSocket, and so on. Like APR, it's 1 thread per connection that needs processing, and it also uses a polar. So a real difference here, the architectures are very similar. The fundamental difference is it's not native code, and so it uses JSSE rather than OpenSSL, which is, that part of it is generally slower. NIO2, generally very similar to NIO. The big difference is how the idle connections are managed. In NIO2, what happens is when you have some data to process, or when Tomcat has some data to process, it writes the data to the IO layer, and it provides a callback and basically says to the IO layer, you get on, do that, and give me a callback when you're ready. So the model for handling that non-blocking IO is very different. So the underlying code is very different compared to NIO and APR. It's not particularly more or less complicated, it's just different complicated. So there is that degree of complexity associated with decoupling a connection from a thread, but you need to do that if you want scalability, and however you do it, whether you do it with a polar or whether you do it with callbacks, there's going to be an element of complexity. In fact, it's the price you pay for the scalability. New in Tomcat 9 is the ability to use OpenSSL with the Java NIO and NIO2 connectors. Here what we do is we wrap OpenSSL and we use it to just do the encryption. It doesn't do any of the IO, doesn't do any of the writing to the network or reading to the network, it's just the encryption we do. Now generally this is faster than JSSE. The great thing is it can just use the JSSE configuration, so it's as simple as just dropping in the Tomcat native library, which as it happens is the same library that's used by the APR connector. Just drop that into Tomcat, it'll automatically switch over now as of the latest code, and it'll start using OpenSSL instead. I say generally faster, that generally tends to vary with a couple of things, and the two main things it varies with are the cipher and the response size. Obviously, you can have an efficient cipher implementation and you can have an inefficient cipher implementation, and projects tend to spend the time on those cipher implementations that are most used. It's certainly the case that there are ciphers that are fast with JSSE than OpenSSL, but they tend not to be the more popular ones. Just as a sort of a quick sanity check, I went and looked up Mozilla's recommendations for TLS configuration on servers, took their modern configuration, took the first cipher in their list of recommended ciphers, so the one that they recommend that you prefer over all others, ran a simple test with that with GSSE and with NIO with OpenSSL, and NIO with OpenSSL was about 20% faster. The other factor is response size. Because you're switching from Java to native code, there is an overhead associated with transitioning from Java to native and back again. So there's a little price you have to pay there. The benefit is once you get into the native code, the encryption is a lot faster. Now, obviously, the gains you get on the encryption side are proportional to the size of the data that you're encrypting. So if you have very small responses, then it's not beyond the realms of possibility that the overhead of switching to native code is greater than the benefit you get in terms of the speed up on the encryption. Obviously, with a larger response size, then the benefit is more likely to be greater in terms of the encryption speed up. So let's look at some recommendations. Fundamental one that underlies everything else: if it ain't broke, don't fix it. These recommendations are intended to provide a guide if you're setting up a new system or if you're facing problems of a performance nature and you're sure that it's connector focused. It's probably worth pointing out that 99% of performance problems we see in apps are actually in the apps themselves. Tomcat adds fairly minimal overhead to total request processing time, and the chances are if you've got a performance problem, you're not going to be able to find that make it run faster option in Tomcat in order to solve it. You're going to have to profile the app, find out where the bottleneck is, and attack it from there. Changing connectors is just as likely to make things run slower than it is to make them run faster. There are so many different factors in play. So unless you're actually trying to solve a problem, then I wouldn't bother changing it just because you think it's probably going to be a little bit faster. So if we're looking at non-TLS connections, so this is non-TLS HTTP and AJP, then NIO is ahead by a whisker of APR, which is a little bit ahead of NIO2. They are all miles ahead of BIO. I wouldn't recommend using BIO at all for any new installations now. It's on the way out, and it's not well suited to a lot of the non-blocking styles, so you really need to pick one of the others. Of the others, they're all pretty similar. I give NIO the slight edge over APR because the non-TLS connections, their performances are all very, very similar. you can probably construct a benchmark that will demonstrate that each of them is faster than the other. It depends very much on exactly how big the data is, how often you flush, how many threads you use, lots of variables. They're pretty much, as near as makes a difference, the same. So NIO is that little bit newer. It's not as well tested, so prefer the others. APR, there is that slight risk of a JVM crash. So looking at those three, given a completely free choice, I would pick NIO. If you're absolutely desperate to squeeze every last drop of performance out of your system, then I'd test your app with all three of them and pick the one that works the best. There's certainly nothing, whilst NIO2 and APR do have small disadvantages, those disadvantages are certainly nothing that would prevent me running it in production if it was the best option for my particular application. And as I say, it will vary from application to application. Once you get on to TLS, then things are a little bit different and complicated by the new options that we've introduced in Tomcat 9. So let's deal with the easy one first of all. BIO, don't touch it, same reasons as before. After that, then if it's raw TLS performance that's important to you, up to Tomcat 8, you want to be using APR. With Tomcat 9, you probably want to be using NIO and OpenSSL, although those two, the performance, again, is very much dependent on the type of load that's applied, so that is certainly something that you are going to want to test. It's certainly the case that in 99% of scenarios, APR is going to be faster than NIO with JSSE, and also NIO2 with JSSE. So in terms of those preferences, as we said, BIO, forget about it. Completely free choice, I'd use NIO with OpenSSL. After that, APR, those two are a little bit ahead of NIO with JSSE and NIO2 with JSSE. But again, if you're on Tomcat 8, you can really choose, test between the connectors, see which one works best for you. Probably APR in terms of performance for TLS. Unless you're seeing stability issues, there really isn't a good reason to use NIO and NIO2 with JSSE. Once you get to Tomcat 9, then NIO and actually NIO2 with OpenSSL are both become viable alternatives for APR, and you really are back into the which one works best with my application. I'll highlight that these recommendations are all general. Every system is different. It really is possible, and I've seen it done, to construct a benchmark that will demonstrate that any one particular configuration is better than another. It's very much dependent on how your application behaves, how frequent the requests are, the size of the responses, how often the responses are flushed during generation. All of those things are all going to have an impact on which connector works best in your environment. And I say, you really do need to test it to make sure if you're trying to squeeze that last drop of performance out of the system. So that brings me to the end of what I wanted to talk about. Do we have? Yes, we do have some questions. Right. Okay. Question. First one. Since NIO and OpenSSL requires TC native, what's the benefit of using NIO and OpenSSL over APR and OpenSSL? Complexity of setup is about the same. APR theoretically allows right, okay. So it's one of those that it depends on the application. So with NIO and OpenSSL, you're crossing the Java native boundary every time you do encryption and decryption. With APR and OpenSSL, you're crossing that boundary every time you do I/O. And those aren't necessarily the same because of buffering. So it's going to come down to how much does your app write in one go, and then how do the two connectors behave in that particular scenario. Which one would be faster than the other? Well, APR in general with OpenSSL would be faster, but then again, NIO with OpenSSL in general is that bit more stable. And again, it's all marginal. It's going to be one of those, test it with your application and see. Any idea if NIO plus OpenSSL will also work as NIO plus LibreSSL? That all depends whether you can compile TC native with LibreSSL. I believe the last time we tried it, something didn't quite work. The Tomcat native 1.1.2 branch is actually fairly close to the tip of OpenSSL development. So it depends on exactly how well aligned LibreSSL and OpenSSL are. And it might be possible to fix the compilation problems. To be honest, I didn't look at that any further. Okay, if the Coyote JK connectors were dropped, what supports JK? Coyote JK was just another name for AJP. So it's the standard AJP connectors that support it these days. Any more questions? Take that as a no. If you do think of additional questions, then please do ask them on the Tomcat users mailing list. This presentation has been recorded, and once I've tidied it up and converted the format and everything, then it'll be uploaded to YouTube. I'll be posting to the users list when that's available, and it should be sometime tomorrow. Thank you all very much.